Hello everyone, welcome back to Let's Unbound. So we are in sixth episode of the series, which is sinusoidal function transformations. So in our previous lesson, video lesson, we learned about sinusoidal function. Now it's transformations we are going to do, almost like many transformational effects we learned in the previous lesson itself. So now let's get into the deeper transformations. And here. Sinusoidal transformation refers to changes made to the sine cosine functions. Like usually, the transformations are same, like shifting, stretching, compressing, or flipping, like reflection, dilation, shifting in the sense translation, right? So these things. And all the rules will be same as we did for polynomial functions, exponential functions, like any functional transformation will follow the same rule and it apply for sinusoidal too, right? So general form of sinusoidal function is for sine and cosine. A sine b times x minus c. Though this is important. If you have bx minus c, no, you should take the b common like that. B into then x minus c should be like this. If this, you have to manipulate. If it like this, okay. And y equal to a cos b times x minus c. D. Many unknowns are there, a, b, c, d. So what is a? Amplitude change where modulus a is greater than 1 is a vertical stretch. And if it's the absolute value of a is less than 1, it's a vertical compression. A less than 0. Sometimes a will be negative. That means there is a reflection happened. And it's a reflection across the x-axis, like flipping horizontally. Horizontally in the sense like top to bottom or bottom to top, right? And period is 2 pi by modulus of b, where modulus b greater than 1 is a horizontal compression. If your modulus b is less than 1, it's a horizontal stretch, right? So whichever we multiplied inside a function, it represent horizontal thing, right? So if it's greater than 1, it's a compression. Less than 1, it's a stretch. Less than 1 and this. And see horizontal translation by c units. So it's a translation, C units. So if your C is positive, negative means it's right side, left side, you have to mention. D is vertical translation by D units. So all this transformation rule is very similar to what we did before. There is no changes in that. If you do something outside, it's vertical. If you do something inside, it's horizontal. Inside, like horizontal stretch, that will be reverse way of describing all those stuff. Now, a for amplitude, like vertical stretch or compression, flip if negative. And period is B also affects the transformation of period and also effect on the graph is horizontal stretch or compression based on the number B. And its period is can be calculated by 360 by mod B. This is one important. We will use it many places. And C means phase shift. Actually, we can say horizontal shift. For this sinusoidal, we use the word phase shift. Horizontal shift, it moves graph left or right depending upon the C value. And D is vertical shift, moving the graph up or down. Let's explore the sinusoidal function transformations now with the help of decimals. Here we go. So y equal to a sine b times x minus c plus d maybe. Right. This is the way we learned, so I'm just converting like this. And this is sine function because everything I kept a is 1, b is 1, c is 0, d is 0. The additives I made 0 and multiplicatives I make it 1. So it's simple sine x, the parent function. Now, let me see what if I increase my a. Okay, the red graph is a transformed one. I just increase a, it's greater than 1. It's like vertically you're pulling up, right? So you're stretching the graph vertically when your a goes greater than 1. Okay, what if it's a is 0? Let's see. A is 0, what happens? The red line, it becomes like this, right? Now, because it becomes a line, y equal to 0, it becomes x-axis. Now, if I go less than 0, negatives, right? The red one, it's just a reflection. Can you see? The blue got reflected along x-axis. That's how it looks like. Okay. So it got reflected from here to here. Now let me keep my A. Okay, A, where this is horizontal, like greater than 0, it's stretching vertically. 0, it becomes a line, and then it's stretching, compressing vertically. Vertical compression and stretch. And when you change the B, what happens here? The graph is actually the pattern. The wave pattern is quickly attained. Like till pi, it got attained many patterns. But till pi, when you see the blue graph, it's just one uh, concave down thing is done. But here, it's many patterns have been completed. So this will affect the period of the graph, right? The frequency is getting more and more when I increase my B. When I decrease my B, usual graph is attaining its part in 0 to 2 pi. But the same graph, when you make your B, it takes 2 pi length to complete one pattern, right? So that's it. And next one is C. Okay, let me make B as also 1. A also 1. Okay. Then C, let me just change this. When I increase C, it goes to the right side. Correct. It moves right side. When I decrease C, it moves left side. That's it. So it's a phase shift, we say, especially here. Like it's nothing but like a horizontal shift. Okay. Now let me make C as 0 and D when I increase, the graph is not changing its shape, but it's just moving up and down. So that's simple. B will affect the periodicity. It will quickly attain cycle. And this one. Right? This is a transformation effects. I hope this might be helpful. And now we are moving to the next. Question 1. A sine function has the following properties. The maximum value is equal to 4 and the minimum value is minus 2. Period is 90. Phase shift is 15 to the right. So A sine bx minus c plus d. How can you find A here? Okay, I can solve it here itself. A is amplitude and it's nothing but maximum minus minimum by 2. Okay, so what is maximum? 4. Formula has a minus, minimum is minus 2 by 2. 4 plus 2 is 6 by 2, which is 3. So I got my A, which is 3. Next to find B. B is period formula, period formula is 2 pi by, here if it's degree given, you can put 360. 360 divided by the modulus of B value. But I want B value now. So we can change the formula 360 by the period of your graph. So 360 by 90, which is 4. So your B is 4. C is phase shift and they clearly mentioned 15 to the right. So C is 15. And D. D is midline, right? How will you find midline? Max plus minimum by 2. So it is 4 plus minus 2 by 2, which is 1. So y equal to 1. Maybe we can say the midline or D value is just 1 and C value is 15. That's it. Our equation got completed. F of x is 3 sine 4x minus 15. Don't put 4x minus 15. 4 times bracket x minus 15 plus 1. If you want to go with a simplified manner, 4x, you can take it, but it's better to mention in the standard form instead multiplying all this. Right, so that's it. We did this problem. And now we are moving to the next part. Question number 2. A cosine graph completes one full cycle between x is 0 and x is 180. The graph starts at its minimum value of minus 5, reaches a maximum of 3, and has a midline at minus 1. Write equation of this function. So generally, a function will look like, if I write g of x as its name, a sine, then b times x minus c plus d. But it not necessarily everything is done. It might not have the midline other than 0, right? It might not have a phase shift. So we have to go with whatever they told here. A cosine graph, so they said it's cosine, so I should change this to cos, right? Right. So this is cos, one full cycle. That means the period is on 80 degree. Okay. Usually, cos period is 360. And your period is like this period is actually 180 minutes. To find the B value, like the OG period divided by the new period, just to divide, you will get the B value, right? So I got my B, which is 2. So B is 2. And then also they mentioned maximum minimum. Okay, somehow I did here. Okay, please note it. Okay. Now, maximum is 3. Minimum is -5. Using that, I can find amplitude. If you know maximum amplitude is maximum minus minimum by 2. So 3 minus in formula, this is -5 by 2, 8 by 2 is, okay. And it has a midline at -1. So D value is -1. So we need to find the phase shift. Did they mention any phase shift here, or like you have to look for any clues, but no clues, right? Now here you see, its minimum is -5, its maximum. Okay, so we have to, if it's a cosine graph, it will start at max, right? So do you remember? It starts at maximum, and this is how, and end at maximum, one minimum it will attain in one cycle. The graph start at minimum means, like the graph starts here, so it will go something like this. So this is reflection, right? So just opposite of it, right? So it's a reflection. So for sure, the reflection means A value should be negative. Already I got A, but for reflection, when I plug in, I will use -4. So G of X is -4 cos your B is 2x, no phase shift, nothing about the shift horizontal given, and then -1. -4 cos 2x -1. Right. Next part. Last question. Compare the following two functions and describe all the differences in the transformation. F of x is 2 sine x. G of x is -2 sine 3x minus 90 degrees plus 1. So let's see the table here. So like important features, amplitude is 2 here. Here also 2. Don't put -2. Amplitude is always positive. Take modulus of the A value. Reflection, no reflection because I didn't see any negative sign. Here is the reflection because of the negative sign, right? Reflection along x-axis. Period is 360 because no B affecting your x. Your x is not getting affected by some multiplication, like right? 360. But here x has got affected. But you have to take that 3 outside. So this is the how we should write 2 sine. Take 3 outside, it's x minus 30 plus 1. Right? So that's why this is my B and I should divide by 3, which is 120. 360 is the OG period of the sine function. And 3 is what I got it from the equation and I divided. Phase shift none here because nothing is added or subtracted with x. So no. But here the phase shift is 30. Okay, so we should take that 3 common. And vertical shift none, nothing is added. Here it's something is added with the function. That is +1 means up by 1 unit. So how can you connect these two? G of x is you obtained by reflecting the f of x. Okay, reflecting f of x, you got a minus. Then the horizontally we compressed by multiplying 3 and then by subtracting 90, we just shift them horizontally and adding 1 also give the shifted version. So G of x is connected with f of x, but after doing multiple transformations, right? That's all for this video and it's time for bonus question. So take a screenshot and do solve the problem. And yes, that's all for today's lesson. So I hope this video might be helpful. So if you have any doubts, queries or concerns, feedbacks, you can share it in the comment section. Thank you. Keep learning. And if you want to join student community, do join by scanning the code given here. Keep learning, keep practicing, stay curious.